¿Qué tal? ¿Qué tal? Un día 3 minutos, un día 3 horas, 2 minutos 35 segundos para lanzamiento del SLS. ¿Qué tal? Como corresponde, paso a saludar. Rodrigo Pérez dice, buenas Dani. Rubén, ni que hablar, siempre ahí al firme. Marcos, de Recorrer Uruguay, dice, deberían transformarlo en un museo, como hace SpaceX con los prototipos, y contratar a una empresa que sí sepa hacerlos. La NASA se metió en un baile más grande que una casa, la verdad, con este cohete, porque es espectacular esto que están haciendo, pero es demasiado complejo.
I just would like to inform you your conference will begin in approximately 28 minutes. Thank you for your
Oh,
patience. Your conference will begin in approximately 28 minutes.
bueno,
Thank
pues
you.
28 minutos de retraso la conferencia. Parece que con esto del SLS se le está haciendo costumbre a la NASA, ¿eh? Yo no puedo creerlo, sinceramente. Esto es una cosa que jamás me pasó con algo de los Estados Unidos. Jamás. Jamás. ¿Ah? Y no es la primera vez que pasa ahora con lo del SLS. ¿No? Yo no puedo creerlo, la verdad. Bueno, tenemos una diferencia de 3 minutos con la NASA en el lanzamiento, así que ahora después lo vamos a corregir eso, ¿eh? Y no aparece el chat en la pantalla. Vamos a revisar a ver por qué no aparece el chat en la pantalla. Rubén que dice, buenas Walter, Miguel Egeltetti, paso a saludar rapidito. Alex Barberá, Ana Gabriela Jiménez, hola Ariel, buenas tardes comunidad. Adrián Marcelo Ferecín, muchas gracias a todos por estar ahí. Marcelo Granero, Óscar Agudelo, Adri Sánchez también. Otra mujer más que se suma, qué bien. Catalán dice otra vez complicado, yo no puedo creerlo. Así que bueno, voy por la cena, ¿eh? Voy por la cena mientras queda esto. Estoy en el chat, me sumo al chat y vuelvo en un ratito, enseguida. ¿Sí?
Thank you for standing by. Your conference will begin in approximately 25 minutes. Thank you for your patience. Your conference will begin in approximately 25 minutes. Thank you. Please stand by. Your conference will begin in approximately 20 minutes. Thank you for your patience. Your conference will begin in approximately 20 minutes.
Como ya casi en hora, esperemos que bueno, que NASA arranque. Volví justito, dice Miguel Ángel Teti. No sabemos quién va a estar hoy en la conferencia, ¿eh? Patuca, ¿qué tal? Bueno, tenemos algún tema que el chat no está saliendo. Vamos a reiniciar nuestro OS un segundo.
Today to review the overnight operations and the additional analysis requested during yesterday's mission management team meeting in preparation for launch. Teams are proceeding toward a launch on Wednesday, November 16th, during a 2-hour launch window that opens at 1:04 a.m. Eastern Time. Here to give us an update on the countdown and launch operations, as well as today's mission management team meeting, are Jeremy Parsons, Deputy Manager for the Exploration Ground Systems Program at NASA's Kennedy Space Center, and Mike Serafin, Artemis I Mission Manager.
Bueno, está Mike Serafin también.
Jeremy and Mike will share a few opening remarks, and then we'll take questions. Reporters on the line can enter *1 on your phone to be entered into the question queue at any time.
Pep Compañón, saludos de Cataluña, gracias. Ángel Encao, ¿qué tal? Vamos a escuchar un poquito.
So per plan, the team was on console for call to stations at 1:24 a.m. this morning. Countdown to, so far is proceeding very well, and we are on schedule. So what have we been doing since the discussion in the conference last night? So last evening, we powered up the vehicle. We ran a series of what we call program-specific engineering tests, or PSETs. It's basically integrated vehicle testing, and all was nominal. So it was a very thorough check out of the vehicle.
Chequeamos el vehículo y está todo nominal, dice, ¿no?
We're getting panels and valves all configured for cryo loading.
Está todo configurado para cargar el combustible. Energizamos la cápsula Orion. Así que la cuenta regresiva se mantiene. Estuvieron chequeando el conector que dio problema, del que hablaron anoche.
What you can expect tonight and into tomorrow in terms of launch countdown. So tonight we're going to begin charging all the flight batteries on the vehicle.
Van a cargar las baterías del vehículo hoy. Van a presurizar los tanques. Van a hacer mañana una serie de chequeo de comunicaciones.
We pick up with our blast danger area clear at 12:04.
Mañana 12:05 hora del este van a dejar el área libre. Mañana que sacan todo el personal de allí. 14:25, están hablando de hora UTC. Van a hacer un hold de 2 horas 30 minutos ahí. El tema de los evaporadores y el tema del combustible. Y van a hacer un procedimiento mucho más lento de carga de hidrógeno. Van a hacer la carga de hidrógeno líquido y oxígeno en paralelo, al mismo tiempo. 15:24, el director de vuelo esperamos que va a dar ahí la autorización para cargar. Tenemos 2 horas de ventana de lanzamiento. Hablar Serafín. Enviaron el cable del conector ese.
We did that change out and then performed a series of retests. Team did a really good job wringing out all of the data, determining the wrist posture, looking at all measurements flowing through there, where redundancy occurs, what launch commit criteria are.
Bueno, parece que cambiaron eso. No entendí si dijo que estaba bien, ¿eh? Evitó decirlo, me parece.
Transients during power up, so they would go out of kind of expected ranges for a little bit when you first power up, and then they would come back into nominal ranges. We are already in a powered up configuration on all of the core stage ICPS and Orion, and we are going to remain in that configuration through the rest of launch countdown. So all of these are kind of at a normal, stable configuration. That being said, we went through each of these launch commit criteria that are associated with these measurements, determined criticality, redundancy, and what we call pre-planned contingency procedures, which is basically allows us to say we take failures on any of these measurements, say we know we have redundancy in these other measurements, and we are still okay to launch. The unanimous recommendation for the team was we were in a good position to go ahead and proceed into launch countdown.
Y la recomendación del equipo después de todo esto es que podemos seguir adelante. Tenemos un sistema muy robusto acá. Va a hablar Catherine, no sé qué Catherine, porque no tenemos lista.
Thank you. We'll go to Mike Serafin next.
Okay,
Mike Serafin va a hablar.
For continuing to follow the Artemis program and the Artemis I mission. This afternoon, we had a launch minus 1 day mission management team meeting.
Mike Serafin es el administrador general, o sea, el gerente general, vendría a ser, de la misión Artemis.
The first was the status of the liquid hydrogen umbilical electrical connector located at the J8 port that Jeremy described, and we went through a status of the connector removal and replacement and the work that was completed, any findings that we had as a result of it, and then the post removal and replacement systems status checks. Right now, as Jeremy described, we don't have any changes to our posture as we head into the launch attempt. The launch commit criteria were reviewed, and we agreed that the as-written launch commit criteria were the appropriate posture to have headed into the next attempt. And that's largely based on the fact that we have systems redundancy as it pertains to the signals that we need to verify as part of those launch commit. The other item that we talked was the one open action that we took out of the launch minus 2 day review held yesterday, and that pertained to the Orion room temperature vulcanization material, or RTV material, delamination that we saw during Hurricane
Hablando de lo que
on the
de
side of the vehicle, or
eso que se
roughly
soltó,
in the
esa
Orion
cinta, ¿no?
270 degree location on the aerodynamic shell called the ogive, where that meets up with the crew module adapter. We had a strip of that RTV delaminate during the storm, during the windy portion of the storm. And
Eso es a causa de la tormenta.
Essentially to fill in the gap that exists between
De lo que está hablando, o sea, hubo dos problemas. Uno fue con un conector, ¿no? Y lo otro es con una cinta que une la ojiva de emergencia, que extraería la cápsula en caso de una emergencia, ¿no? Es como una especie de cinta que une las dos cosas, que son láminas, y el viento lo delaminó, o sea, soltó las láminas y hace que no quede completo, ¿no? Ellos tienen miedo de que eso, lo voy a poner para que lo vean. Ahí está. Es esto que vemos acá. Es esto negro que se ve, esto blanco de acá, o esto que está acá, que se saltó un pedazo, y tienen miedo que se siga saltando en el momento del despegue y dañe algo del cohete más abajo.
From the Orion spacecraft all the way down to the base of the stack, and we agreed that the risk was bounded by current hazards and hazard reports that we have out there well before that were established well before the agency flight readiness review, and when we accepted our risk baseline at the agency flight readiness review. So we went through that today, and we closed that action item, and we accepted that flight rationale. And it just was one of those circumstances yesterday where the team needed a little bit more time to assess our overall risk posture and to understand this new issue that had occurred earlier or mid last week as a result of Hurricane Nicole. So we went through that. I asked if there were any dissenting opinions. There were none, and we accepted that flight rationale. So that was
Dice que aceptan los riesgos.
Launch minus 1 day mission management team meeting. We are proceeding to the next decision gate to set up for the November 16th launch attempt, as Catherine indicated at the outset. So there's no change in our plan to.
Dice que no hay cambios en los planes de intento de lanzamiento, se mantienen.
Tomorrow afternoon at 2:30 in the afternoon Eastern.
Sí, yo pondría, hay unas cintas que se usan en aeronáutica justamente para este tipo de eventos y están aprobadas justamente para eso.
Tomorrow afternoon, and I'll pass it back to you, Catherine.
Thank you. We'll now begin our question and answer session and take questions from reporters on the line. Those on the phone.
¿Alguien tiene alguna pregunta para hacerle? La escriben en el chat con la palabra pregunta adelante y tratamos de colocarla.
Please identify to whom your question is addressed, and we ask you to please keep it to one question so we can get to as many reporters on the line as possible, and if we have time, we will do a second round of questions. We'll start with Kristen Fisher of CNN.
Thank you both so much for taking our questions tonight. Two questions for you, and I'll try to keep them brief. I just want to make sure that I have it right in sort of, layman speak. Would it be fair to say that these two issues that have given you guys some trouble over the last 24 hours or so, the damage caused by the hurricane, that the the RTV material and this umbilical, that those two issues have been fixed, or that you all are just now comfortable with proceeding with them as is? If you can just kind of give some clarification as to how we should refer to that, I would appreciate it. And then my second question is, if each of you had to pick one moment in the countdown between now and liftoff that gives you the most heartburn to think about, what moment would that be? Thank you.
Yeah. Hi, Kristen. Thank you for the question. In terms of the two issues that we reviewed today at the Launch Minus 1 Day Mission Management Team meeting, I would say that we're comfortable flying as is in both of those cases. We did attempt to fully resolve the electrical connector on the tail service mast umbilical, and we're still seeing some funnies on that particular umbilical, but we reviewed.
Dice, hemos trabajado en eso, hemos cambiado, están dando, hemos visto algunas funnies, dijo, eso es divertido, es un diminutivo de divertido, no tiene una traducción exacta, pero como que hace algunas fallas cada tanto, pero tenemos redundancia, dice.
Yeah, that's a good question. I haven't had time to think about that one. Nothing immediately comes to mind. This is something that is it's something we've been preparing for, and we've trained for, and there are a number of decision gates that we have purposely to set up to review our risk posture in the event that something changes, like we saw here as a result of Hurricane Nicole. And I see the team that's prepared to do that. So nothing comes to mind. I don't know, Jeremy, if you have anything to add to that.
Well, kind of given the white dress rehearsals, for me, I'll probably breathe a bit of a sigh of relief after we get into LH2 fast, slow fill to fast fill, right in that time frame. I feel very confident in the procedures that we've worked, but that'll be one of those things where I think it'll be a big milestone once we really get into a steady state fill of LH2, and so that'll be around 4 p.m. or so tomorrow afternoon. So that'll be something I think we'll all be watching closely.
Thank you. Our next question is from Marcia Dunn of the Associated Press.
Yes, hi. Mike, I'm trying to get a better understanding of the RTV, comfortable flying as it is. Is it that you don't think any more might come off or if it does come off, that it won't hit the rocket, or if it does hit the rocket, it won't do big damage? I mean, what's your thinking along the lines of risk in that regard?
Están preguntando
Yeah,
respecto al
Marcy,
riesgo
that's a great
si no
question.
golpea el cohete en caso que se suelte
There
algo
is
más de eso en el despegue, ¿no?
a
Que pueda
small
dañarlo.
likelihood that more RTB could come off the vehicle, but we do have flight rationale that supports that. In order to have an issue in flight, first of all, we need additional RTB to be released, and then it needs to impact part of the vehicle, and that vehicle element has to seek what we call critical damage, and there are limited components that could be exposed to that just due to what we call debris transport and where these objects are relative to where the RTB would be liberated from. So we look at things like, is this within our experience base? Are there self-limiting aspects of this particular material and material release? And we do have self-limiting aspects, like the fact that it is going to tear because it is very pliable, and when it gets into the airstream, it's not going to come off as one really long piece. It will basically break into smaller pieces. And then we do know that this particular material has a very low lift coefficient when you look at it aerodynamically because of how pliable it is. We actually had a witness sample in the meeting today. It was about 12 inches long, and I believe that we've also posted photos online of where we've lost the material for the general public to help.
Está hablando que tuvieron una muestra hoy en mano, justamente.
It is very thin. It is
Dice,
relatively lightweight.
es relativamente liviano, es muy fino.
Low lift coefficient, the fact that we have a physics-based explanation, the fact that it has self-limiting aspects, the fact that we have an experience base of flying with this material and not just on Orion, but with other programs.
Hemos volado con este material en otros programas.
Aerospace material, but we also flew ascent abort test number 2. We flew exploration flight test number 1. We had RTB in a very similar area in both of those test flights, and we did not see material at this same interface liberated during the aerodynamic flight there. So we do acknowledge that there is a non-zero chance that we could have additional liberation of RTB in flight, and that there is a possibility that it could impact a different area of the vehicle downstream of Orion. We know what those areas are. We looked at it all the way down the stack.
Aquí tenemos el material que se ha perdido.
To have the RTB impact the Orion vehicle is on the launch vehicle stage adapter. The launch vehicle stage adapter is a very tall conical feature that sits between the top of the core stage and the base of the interim crowd propulsion stage, and it literally takes the diameter of the Orion spacecraft and extends out to the larger diameter of the core stage.
No recuerdo, pero creo que fue 13 y algo UTC.
Area is there, that becomes the most likely area. The LVSA is a very robust piece of hardware. It weighs about 10,000 pounds, and it is used to translate the 8.8 million pounds of thrust at liftoff of the boosters and the RS-25 engines up into the
18:30 UTC comienza la cobertura.
Spacecraft that sits above it. So it translates 8.8 million pounds of thrust up into a spacecraft that weighs over 70,000 pounds, and I don't remember the mass of the interim crowd propulsion stage, but you know, we're talking tens of thousands of pounds there as well. So the launch vehicle stage adapter is a relatively inert piece of hardware, and that's the most likely. It's simply a structural adapter, and that's the most likely area that it could be exposed. But there are other areas that we looked at, again, because of the particular material type that we're talking here, and other risks that we have disposition in the past or have in our hazards, like ice and the thermal protection system on the core stage. We considered this to be bounded and within an acceptable range of risk. So that was our flight rationale.
Dice que es racional.
Thank you. Our next question is from Bill Harwood of CBS News.
Yeah, hey, thanks. I'd just like to follow up on Kristen's earlier question to Jeremy. What do you think the odds are with or I don't know, I'm not asking you for odds, but how confident are you that when you get into fueling that you won't have to do manual adjustments like you've had to do in the past, with pressure and flow rates and temperatures management? I mean, how confident are you might be able to just load the fuel and go? Thanks.
Hablando de la carga de combustible, y si lo han tenido que hacer manual, y si lo van a hacer, no lo van a hacer directo de cargar. Hemos validado estos procedimientos durante con el intento de lanzamiento número 2.
What is the environment around these quick disconnects? What does the seal look like? What are the pressures we're putting on there? And then the associated leak rates. I would say at this point in time, we are more confident than we have ever been in our loading procedures and how to do it in such a way that puts the least amount of pressure on the seals and to really try and keep it quiescent. The other thing is we have a purge can, right, basically around these quick disconnects where, we try and remove, we purge it consistently with helium. And so, and we have hazardous gas measurements kind of coming through there. We've talked with all of our requirements, and we're allowed to have, a momentary transient as we, up pressure, because, again, you don't have any, it would just be for a short time period. And that's really the worst case that we saw during this tanking test, was you saw kind of a brief spike of hydrogen when you introduced, more than a couple of PSI worth of pressure, and then it quickly came down. And so we've accommodated for all of that in our test procedures and in our safety requirements. So feeling pretty good.
Luis, gracias por estar.
About that kind of going into.
Sí, el lanzamiento se mantiene. Está en el primer mensaje.
Our next question is from Nell Greenfield Boyce of NPR.
I'm just wondering how you all are feeling. There was a huge amount of attention back in August, and then there were all kinds of things that have happened, the faulty sensor, fuel links, Hurricane Ian, Hurricane Nicole, and here you guys are again. I'm just wondering, Jeremy, could you tell us, does it feel real now? What's the feeling of the team?
Después de todo lo que ha pasado, ¿se siente real
esto? It's a very
esto?
elegant question, but I guess you know what I'm asking here.
Parece.
I know it's a good question. What I'll tell you, if I step back, what I feel is extremely proud of the resilience of this team.
De lo que siento, que estoy muy orgulloso de todo este equipo.
For all of us, right? It was a bit of a letdown when we had to roll back for Hurricane Ian. What I was so impressed with is the team turned around. We were kind of down that night. Then by the next day, everyone was super focused on what work we needed to do, what we needed to do to get back out at the pad, and then it was a similar story for Hurricane Nicole. By late afternoon, the day after the storm left, we had completed all walkdowns, we had completed imagery. Any issues were largely behind us. I mean, I will tell you, the team is firing on all cylinders at this point, and so I just can't be more proud of them, because I think if you would have asked me a couple of weeks ago, we would go through a storm like Hurricane Nicole and then be able to turn around and have cleared the vehicle and be in good shape. Probably low, but this team has really just been firing on all cylinders.
Yeah. And no, I would add that the word perseverance comes to mind. The team has had to persevere through numerous trials, and that perseverance in turn has developed character in the team, and that gives me comfort that we're going to be ready when it's our time to fly. As our administrator said, we'll fly when it's right. And Administrator Nelson is he stands there with us, understanding that we've got to get this right. And in spite of the challenges that we've had, the hydrogen leaks and the storms and the other technical issues that we've had, the team has done a great job, and as Jeremy indicated, they've persevered through a number of situations, and our time is coming, and we hope that that is on Wednesday. But if Wednesday is not the right day, we will take that next hurdle, that next trial, and we'll persevere through that.
Thank you. Our next question is from Joey Roulette of Reuters.
Hey, thanks. I just had one follow-up on the RTV issue, I guess, for Mike Serafin. What other risks does this present that doesn't have to do with the potential for debris hazard? What does this, I guess, mean for the aerodynamics during, ascent? What kind of forces are you guys going to expect to see now that a lot of the RTV is now gone? Thanks.
Yeah, Joey, that is a good question. We did review the aerothermal and aero heating aspects of it, knowing that we had a portion of the RTV on the currently east-facing side of the spacecraft, and because we already have an aerodynamic barrier that sits there, our aerothermal models and the analysis the team has done shows that there's not an issue there. This was just a way to reduce the aerodynamic turbulence and flow in that particular area, but we're within our allowables. In terms of other risks that we talked through, that and debris liberation were the two primary areas that we focused, and really nothing else comes to mind in terms of what we needed to address. It was just the debris liberation flight rationale that we needed a little more time to go resolve. But all the other aspects of the risk were characterized yesterday, and so I would say that really covered the gamut.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks. This is for Mike. Does the RTV issue change the original loss of mission odds? I think you told us it was 1 in 125 back in August. And also for Jeremy, do any of the changes that you're making to the fill affect the 489 launch commit criteria? Any more, any less? Thanks.
Yeah, Irene, in terms of the loss of mission or loss of mission number, or the 1 in 125, which is the loss of vehicle number that was quoted earlier, and we assessed as our risk baseline at the agency flight readiness review. Again, if you look at maybe a couple of decimal points past that 1 in 125, there's probably a marginal increase in risk due to the potential for the RTV to be liberated and then follow a very specific trajectory and hit a very specific component and cause what we call critical damage, which would essentially result in loss of functionality. We see that as a low likelihood, but there is a chance there. So in terms of changing from 1 in 125, there's no material increase there. But if you were to go several places after the decimal point, I'm sure there would be an increase. But we consider that an acceptable delta to the risk, and that is the purpose of the mission management team, is to review any changes from the risk baseline at the agency flight readiness review, and we did that today.
La cosa que hacen, dice, es tratar de mantener el delta, el aumento del riesgo bajo, dice, y eso es lo que hacemos en las revisiones. Y de la perspectiva aerodinámica,
went through the hypothesis that more could be liberated during the ascent phase, knowing that
hemos ido en la hipótesis de que podría haber sido liberado un poco más. No sé si la resistencia aerodinámica.
1 in 125, and I'll let Jeremy answer the second part of your question.
So, Irene, in terms of LCCs, I will have to verify. I don't believe we changed any LCCs as a result of the loading procedure, but I will verify just so I'm not giving you kind of any bad information. At a top level, it doesn't increase our risk posture. The primary downside with kind of the longer LH2 loading procedure is just additional commodity usage, and what we put into place was careful analysis to make sure we can get through the load, get through the full 2-hour window, and then we have a full replenishment schedule in place in the event of a scrub, and so that's just basically orchestrating along those lines. And really, after a couple of those wet dress rehearsals and initial attempts, we have a very, very good feel for our models on commodity usage, and so that was the primary downside by extending that out.
Thank you. Our next question is from Jeff Faust of Space News.
Good evening. Question for Mike Seraphin. You mentioned the launch vehicle stage adapter is the most likely component that might be hit by any RTV material that delaminates during flight. What are examples of less likely but potentially more serious impacts? Are there other components that are more vulnerable to an impact that might cause some of the critical damage that, while unlikely, is potentially theoretically possible?
Hi, Jeff. Thanks for your question. Yes, we did look at less likely areas. Again, if you look kind of nose on at the rocket as if it's literally flying right at you, and you have this RTV at the nose of the rocket, and a piece of it were to come off, you need to look at the surface area that's downstream, and as a piece comes off, really the only area or time frame that we're exposed to having enough energy where the mass of any RTV
Muy interesante.
follow a very specific trajectory and impact the vehicle downstream is in the Mach 2 to Mach 3.5 range, or about 80 to 100 seconds in the flight. So now if you look at that's your narrow window of exposure where you have enough energy, where the rocket is accelerating fast enough, but there's enough atmosphere to slow down anything that comes off enough that you have enough impact energy. The areas from highest probability to lowest probability were on the launch vehicle stage adapter, simply because it is a large diameter change from the diameter of the spacecraft to the diameter of the core stage. The next most likely area were the inner areas of the boosters, the solid boosters, and when I say the inner area, the areas that are closest to the core stage, because if you're looking at the far side of the boosters, the ones that are pointing away from the core stage, there's no risk of this RTV impacting the booster. So booster was considered moderate relative to the LVSA. And then the core stage and the interim cryo propulsion stage were seen as low probability. There were some specific areas on the interim cryo propulsion stage that we looked at, specifically the systems tunnels that are small aerodynamic protrusions where we run some wires and cabling up the sides of the stage. And then similarly for the core stage, there's cable trays and some systems tunnels there. The boosters were considered moderate probability, mostly because of some very specific areas, the separation motors at the very base of the booster.
Bueno, estaba comentando de que el peor momento se da cuando el cohete alcanza el Mach 2, entre Mach 2 y 3,5, eso es a los 80 y algo de segundo del despegue, y que el peor lugar donde podría llegar a impactar y tener energía, porque ese es el tema, no importa solo la velocidad del cohete, sino de que tenga energía, y para que tenga energía tiene que haber atmósfera, entonces tampoco puede estar muy alto. Es una mezcla que no sucede, porque cuanto el cohete más alto está, menos atmósfera hay, menos resistencia y menos energía podría tener la pieza que se suelta. Bueno, pero en el peor de los escenarios dice que podría llegar a golpear donde se juntan las interetapas, pero que la forma en que tiene allí el cohete también hace muy poco probable, ¿no? Y también hay unos lugares donde hay unos cables que pasan por unos ductos por fuera.
We've gone through the green run, we've gone through tanking tests. couple of launch attempts, a couple of storms, hydrogen leaks. It seems, and this is a terrible question to ask an engineer, and I'm sorry, it seems like you're in a good spot. What does your gut tell you? Are you going?
David, I'll know the answer to that question, in the early hours of Wednesday, the 16th, if we're going to go. We are going to set
Hice
up
recién un resumen,
our
Mar
best,
Víctor.
and we're going to try on Wednesday. That said, if we have an issue that occurs that would cause us to meet one of our no-go criteria, it may not be our day. As I've discussed before, we really have three buckets of criteria that could cause us to be no-go. Our launch commit criteria, our technical.
Si el daño fue causado por la tormenta Nicole, Luciano.
We have range safety criteria in the interest of public safety, and if we had somebody out there or a situation that there was a range safety risk that was not handled or managed, we may have to halt. And then weather, relative to meeting our weather criteria. On Wednesday, we have a very favorable weather forecast. We've seen very favorable weather forecasts turn into no-go conditions in the past. I hope that's not the case, but we've also seen very poor weather forecasts turn into a go and launch. So, the answer to your question is like trying to predict the weather or predict, whether we're not.
Walter Baez, mirá el contador ahí abajo, en rojo. Falta un día, 5 horas, 57 minutos.
Shot on Wednesday, and we're set up to do that. I'm hoping that all the systems line up, the weather lines up, and the range lines up.
Dicen que es muy bajo el riesgo.
We're not going to commit this vehicle until it's time.
Thanks. Our next question is from Chris Gebhardt of NASA Spaceflight.
Hi, yes. Two quick questions here. From the fueling test on September 21st, you allowed the ambient LH2 concentration limits to go up to as high as 10% with really strict monitoring on that. And I'm wondering if that's the case for Wednesday, or if the limit is back to 4% with the option to increase back up to 10% for troubleshooting purposes, since you have the data from the September test on that. And then also back to the RTV issue. I guess I'm having trouble wrapping my head around this. If Nicole, with winds of 75 miles an hour, liberated this, doesn't that tell you it would have come off as soon as the local airstream reached speeds greater than 75 knots? And how does that factor into...
Bueno, está preguntando lo que mucha gente se pregunta, ¿no? ¿Cómo puede ser que la tormenta Nicole de 100 y algo kilómetros por hora haya soltado esa parte entre el cohete? ¿Qué es lo que va a pasar entonces cuando el cohete alcance esa velocidad en el despegue, no? Bueno, en realidad pasa de que la velocidad del cohete es vertical y la tormenta es tangencial totalmente, algo que no se da nunca en el despegue. ¿Ah? Puede haber una componente lateral, que es una de las cosas que restringe el lanzamiento en caso de que haya cizalladura de viento, pero no hay viento lateral tan fuerte.
Stop and revert flow sort of condition, again, we are going to allow that 10% for a small period of time until the pressure kind of equalizes. So we are going to keep that in there, and I think we found that is going to be beneficial.
And Chris, as it pertains to the RTV delamination from tropical or Hurricane Nicole, with winds that were 70-ish knots relative to the launch profile, we have flight experience flying around.
¿Nadie tiene una pregunta para hacer?
Both on ground test or suborbital test, as well as an orbital test. Exploration Flight Test 1, I was the lead flight director for, and we launched an Orion spacecraft up to 3,600 miles above the Earth. We did not see anything like this on that flight. And then on Ascent Abort Test 2 in 2019.
¿Se nos cortó? Se nos cortó, yo no puedo creerlo. Bueno, vamos a ver si reconectamos.
Welcome to the Conference Calling Center. Please have your passcode and conference leader's name available. A coordinator will assist you momentarily.
Thank you for calling. May I have your passcode, please?
Oh, yes, I was on the conference call and I lost the call. Daniel Riguera, Artemis.
Thank you. And your first and last name with the spelling?
Daniel Riguera. You just have my name. I was on the conference call. I lost the call.
Okay, I apologize. I can't see who was in before. Can you just spell your last name for me?
Oh, yes, Regueira.
Thank you. And your affiliation?
Drone UI.
All right, I'll join you back in.
Thank you.
You're welcome.
We do have flight rationale that supports even if more material were to come off. And again, there's a small probability that more material could come off, but not all of it's going to come off. That's why we're not particularly concerned with the risk profile here because it's enveloped by other experience that we have.
Thank you. Our next question is from Micah Maidenberg of the Wall Street Journal.
Hey there. Hey, Mike, could you just briefly, remind me about the advantages of using liquid hydrogen as a fuel for space launches, in combination with liquid oxygen? I've done various research and interviews and so forth, but just for all the discussion, we've been having over the last few months about it, just remind me, what are the advantages of it?
Héctor, los boosters son los que ya tenían, que en realidad tienen varios construidos. Les están agregando un cilindro más para agrandarlos.
From a ground perspective, right, liquid hydrogen can be slightly more difficult. What this vehicle has been absolutely optimized for is putting mass into lunar orbit, right? And so that's what you get with liquid hydrogen is very robust performance in getting mass around the moon. And so, this vehicle was designed for deep space exploration. It wasn't designed to put satellites or vehicles into low Earth orbit. It was designed for kind of deep space exploration. And so what you get with liquid hydrogen is the best performance around that, along with a lot of history on the RS-25s.
Le están preguntando por cuáles son las ventajas de tener hidrógeno líquido como combustible. El hidrógeno líquido dice que tiene mucha performance y es lo ideal para mandar algo a la luna.
But it has incredible performance or energy density when you compare it on a mass perspective.
Está bien, Alex, el mensaje de MADE no debería serlo borrado. Creí que era spam, dice, está todo bien, está todo bien. José pregunta si hay algún inconveniente. Bueno, había dos inconvenientes. Uno era con un conector.
Thank you. Our next question is from Lucy Aborge of AFP.
Con un conector que lo cambiaron el cable y dice se está comportando funny, o sea, como que sigue dando alguna falla, pero tenemos redundancia. Y el otro es sobre una unión entre la ojiva de emergencia que toma la cápsula para afuera y la cápsula de tripulantes. Pero dice que el riesgo de que se suelte eso y haga daño más abajo el cohete en el momento del despegue es muy mínimo porque tiene muy poca masa y además la energía que va a tener es por muy poco tiempo y donde podría llegar a golpear no haría daño. Que toman el riesgo, ¿no? Que el riesgo es muy bajo.
that we know has a low state of charge that may impact its ability to achieve its mission, and the other ones all have sufficient state of charge that of the 10 where we expect them to meet full mission duration. So we did look at that as part of our flight readiness review, and then most recently as part of the our Delta launch readiness review. And there's only the one that we're concerned with, which is a science mission that's looking to map the lunar volatiles around the moon. But the rest of them, we expect to have a adequate state of charge on the batteries.
Thank you. Our next question is from Jim Siegel of NASA TechNet.
Thank you for taking my question, and forgive me if you've covered
Jorge Rodríguez, no tienen nada, no.
news conference, but I'm curious about the content or the cargo in the Orion spacecraft, and was there an attempt to add to the weight of Orion so that it would be about the same when it was launched with crew? Thank you.
¿Quieres saber sobre la carga que hay en la cápsula Orión?
We have a slightly lighter Orion spacecraft than we will have on a crewed flight because we don't have the crew plus all their gear, but we do have mannequins, or moonekins as we've called them. 3 of the 4 seats have
tenemos maniquíes, tenemos 3-4 asientos que hacen el peso de lo que serían tripulantes allí, ¿no?
We're missing our 4th crew member from a mass standpoint, but also all the stowage, the food, the clothing, all that other materials that astronauts would normally take with them, we do not have. That said, we do have a series of mass simulators in the vehicle. We do have a series of payloads that we're going to round trip in the Orion spacecraft. We have a biotechnology experiment that we're going to round trip with a number of organisms that we've shared the content online about. We do have a technology
José Mijara dice como pregunta si por fin van a hacer el lanzamiento o no. Sí. Dijeron ya que el horario se mantiene y lo van a hacer. 16 de noviembre, hora 6:04 UTC. Y que es el momento de la prensa de preguntar. Todos queremos preguntar algo. ¿Ustedes no quieren preguntar algo? Ángel, un abrazo. Gracias por haber estado. Nos vemos nuevamente.
From deep space and then out into the deep space environment where we do not have any shelter from the Earth's magnetic field, fly about the moon and then return back through the Van Allen radiation belts and then back into the Earth's magnetic field. We're going to gather baseline data on what our astronauts are going to experience. So we do have a number of payloads and science experiments that we're going to use as we go along. We also have what we call the official flight kit, where we're round tripping certain artifacts, either that are
David,
representative
lee el
of
primer
our
mensaje, es decir,
partnership,
recién entras,
and we've
que es lo
shared
más
that
importante que
information
dijeron.
as well. We have our zero G indicator, Snoopy.
Tenemos un Snoopy, que es el indicador de 0G. Es otra de las cosas importantes que dijeron hoy. Fue el único daño que causó la tormenta, 2 daños. Eso y el conector, que dice que lo repararon, que cambiaron el cable, que está un poquito funny, divertido, como que hace cosas raras, pero que tienen redundancia. De hecho, sí lo tienen. El conector no es un único conector, son una serie y los datos y todo van repartidos y duplicados en varios. Entonces, es cierto. Coral, muy buena.
will be about 58,000 pounds, and then what'll
El
splash
gran
out.
problema es que vuelve, Coral. Si no volviera, yo tengo varios para anotar ahí.
Thanks. Our next question is from David Denault of About Space Today News.
Mike, I may have missed this somewhere, but the rocket was facing obviously in the eastern direction, so you had the direct wind hit. How much of the spacecraft were we talking 3 feet or maybe some meters? How much of that was actually lost? And my second follow-up on this, if this were a critical issue and you had to roll back to the VAB, you said this would take a lot of extra time for this material. If you had to do the whole spacecraft, how long would that take?
Yeah, David, thank you for your question. In terms of how much of the RTV material was lost at the pad as a result of Hurricane Nicole, it was isolated to the windward side, so the direction that the wind was blowing from, which was basically facing the beach, or the eastward direction. If you're looking at it from the
Sí,
Orion
Benja, se
coordinate
puede
system,
abortar.
it's kind of centered on the 270-degree location.
¿Qué tanto se perdió de esa unión? Solo al lado donde sopló el viento.
At one time, we have video of confirming that because of the pliability of the material, and again because it has a very low lift coefficient, that it has self-limiting aspects, and it literally tore off in little strips as the wind grabbed it and created a little bit of lift. So we know in total it was about a 10-foot strip that was released in pieces. In terms of how long it would take, I don't remember commenting on how long it would take. We do not have access at the launch pad to repair this particular location, but it would take the time to roll back, gain access in the vehicle assembly building, time to apply the material.
En caso que tengamos que volver al VAB, dice, tenemos que hacerlo, ¿no? A reparar.
And then we would have to remove access and then roll back out to the launch pad. So there is a finite amount of time it would take to do this. That really did not factor into the flight rationale or risk acceptance discussion. The risk acceptance was strictly based on, do we understand what's going on here, and do we have flight rationale?
Thanks. We've got time for a couple more questions. We'll take the next one from Jim McKenna of Aerospace Tech Review.
Thank you. This one is for Mike. The leak on the LH2 line, the last time, if I recall correctly, was caused by a valve command error that led to the line getting overpressurized to 60 psi. What has been changed in the procedures to prevent an occurrence of that type?
Yeah. Hi, Jim. I'll start, and Jeremy can add anything here that I.
Dice que es un multicapa, Tony.
We don't know definitively that the inadvertent overpressure of the liquid hydrogen line at the start of launch attempt number 2. We don't know definitively that was the cause of the liquid hydrogen leak at the 8-inch quick disconnect. What we do know is that when we demated and reviewed the seal at that quick disconnect, that there was evidence of, we know that there was an indentation on the seal, and it was consistent with either ice or foreign object debris. We did not find foreign object debris, and
dice que hay indicación cuando removieron de que había golpeado algún objeto, pero no lo encontramos. No sé si está hablando del conector o de lo que de la cinta esa que separa, o si fue un shock térmico. Pero no pueden determinarlo.
We did implement some procedural actions and corrective actions.
Ya hemos implementado correcciones en eso, ¿no?
And some additional automation of the software associated with the hydrogen loading operation. So we looked at all the potential causes. We
Benja Manuel, sí es cierto. En aviación se usa también unas cintas parecidas al aluminio, muy adhesivas. Se usan inclusive para tapar agujeros en los fuselajes.
But again, we could not definitively say what the root cause was. I don't know, Jeremy, if you have anything to add to that.
Yeah, I mean, I would just say, the console operator in this case, I mean, he was very experienced, incredibly proficient at what he was doing. What we had done is between launch attempt number 1 and number 2, we had changed a number of the procedures, and going into that, you had to.
Hemos cambiado un montón de procedimientos entre el intento 1 y el intento 2.
That increases possibility of error. We basically put controls where on the command console, you basically can only command one of those things at a time, and everything else is locked out.
Hemos cambiado un montón de cosas de las que se pueden hacer desde las consolas principales para evitar errores. Hemos eliminado muchos tipos de errores. Se mantiene, Carlos Medina, se mantiene.
What we call ICD, or essentially the requirements, specifications for that specific duty, but you still did get a pressure transient. And so what we're really focusing on, and what we validated during the tanking test, was kind of a very slow, methodical raising of pressure, incrementally over a long period of time.
Un abrazo, Alex. Muchas gracias por haber estado.
Any of those pressure transients on the quick disconnects. And so, again, that was validated, and we're utilizing the same procedures that we did on that September.
Bueno, Elon no está en Starbase, no está más.
Thank you. We probably have time for just one more question. We'll take a question from Ken Kramer of Space Up Close.
Bueno, no me tocaron las preguntas.
Hi, thank you for doing
De
this.
fuera.
Good luck with the launch. I would like to ask about the
De fuera de las preguntas esta
rolling
vez.
back the rolling back Artemis. Can you talk about? You said it was riskier to.
Sí, hay que
roll it
llevarlo de
back
nuevo
and
para atrás.
have it on the ground
Dice,
versus,
es riesgoso, pero
being on top of the pad. Why is it more risky on the ground rolling it back versus or stopping there versus keeping it on top of the pad? Thank you.
¿por qué es más riesgoso, dice, tenerlo más abajo que tenerlo allí arriba?
Question. So I think kind of one way to start is that the analyzed loads seen during Hurricane Nicole were less than what the vehicle sees during a roll out and roll back. And so kind of at a top level,
El estrés
those are some of the
que
higher
recibe el
load
cohete en el caso de la tormenta Nicole es menor que el estrés que recibe cada vez que se lleva y se trae al sitio de ensamblaje.
There was a couple of things in the decision. We are single string on the crawler transporter, which means you basically only have one crawler transporter. While it is very robust and we have spares and we have a number of things along those lines.
Tenemos un solo vehículo para
to
llevarlo.
roll back, and winds were expected to pick up within, I don't remember the exact time frame, but there was a window where the winds weren't expected to be high.
Abrazo, David, gracias.
So if you rolled back and then, you had a shoe on the crawler fail or a propeller motor or something like that, there was a not insignificant chance that you could be on the crawlerway when winds exceeded your requirements or lightning rolled in. And again, when you kind of looked at what were the worst case expected conditions out at the pad versus, potentially being stuck on the crawlerway, those were some of the decisions involved in the risk trade there in terms of writing it out. We did look very carefully at, what were the worst expected conditions.
Bueno, dice, miramos mucho justamente en los modelos de diseño, dice, porque si nos agarra una falla de la oruga del crawler en el medio y quedamos trancados allí, no tenemos protección de rayos, no tenemos un montón de cosas y realmente el riesgo es mucho mayor que haberlo dejado en el sitio de lanzamiento. Alguien me resume, por favor, dice Pablo. El resumen está en el primer mensaje. Y eso es lo más importante que dijeron y que también está cargado el indicador G, que es Snoopy, una mascota de Snoopy, justamente, que indica cuando estén en 0G. Son las dos cosas más importantes de hoy.
than if we're rolling, because you need to account when you're rolling.
El
you need
resto
to
creo que
account
esto
for
es
the loads.
interesante, que
The
el
analogy
estrés producido por Nicole es menor
in
que
a
el
pickup
estrés que se
truck
le
going
podía
down a
haber
bumpy
producido si
road.
lo llevaban y lo
When
traían
you're
al
when you're on
sitio,
the crawler way,
al sitio de lanzamiento, de ensamblaje.
rocket. Granted, you aren't moving very fast, but there are loads there, and you need to subtract that out from any wind conditions.
Rod Stewart. Bueno, lo que pasa es que a veces trato de hablar más fuerte que ellos y mi propia voz cambia. Cuando hago esfuerzo en la voz, mi voz cambia mucho.
In that time frame,
Y a esta hora del día
we're in
mucho
the
más.
range that we thought we had more margin from a vehicle structure standpoint, staying at the pad and riding it out than rolling back. And if we rolled back, we would be accepting the risk that we could have a problem with the crawler transporter during that time frame and be stuck out there on the crawler way and not make it back to the vehicle assembly building. And it sounds like a relatively simple and relatively straightforward thing to do, but it is not. This crawler transporter, if you've ever walked up to it and seen it in person, you feel very, very small. And that is without the rocket, 32 stories sitting on top of it, or with the mobile launcher. The mobile launcher itself weighs 11 million pounds. The rocket's dry weight is a little over 2 million pounds. So
11 millones de libras,
mobile launcher
11 millones de libras dice que pesa el crawler, o sea, la oruga, contra 2 millones de libras que pesa el cohete.
you've got tens of millions of pounds going across the ground, and again, it was a risk-on-risk trade.
Por eso que cada 4 o 5 años tienen que cambiar todas las piedras que pisa la oruga porque las muele.
Long discussion that we talked about, and we did not take.
No, la fuerzo solo cuando hablo por encima de la voz de ellos.
Thank you. That is all of the time that we have for questions today. Thank you all for joining us. You can listen
Bueno,
to
se
a
termina
replay of
la
this
conferencia.
teleconference online shortly by visiting the Media Resources tab at nasa.gov/Artemis-1. And join us tomorrow for our launch coverage, which begins with NASA television coverage of tanking and commentary from inside the Launch Control Center,
Bueno,
beginning at
mañana
3:30
comienza.
p.m. Eastern. And you can follow along at our blog for updates about the mission as well at blogs.nasa.gov/Artemis.
20:30 comienza la cobertura. Mañana 20:30 UTC.
Thank you for your participation. Participants, you may disconnect at this time.
Thank you. Have a good night. Vamos a desconectarnos. Eso fue una llamada más a Estados Unidos, ¿eh? Un poquito de música, extraño nuestra música. Bueno, muchas gracias a todos por haber estado acá. Mañana, 20:30 UTC, comienza la cobertura, el lanzamiento. Vamos a hacer una transmisión especial por eso. Y luego vamos a... Quizás hagamos un corte para comenzar la transmisión principal luego más tarde, más próximo a la hora del lanzamiento. Y si hay algo entre medio, estén tranquilos que lo vamos a pasar. Vamos a estar allí, ¿sí? Adrián Marcelo Ferrecín, agendado. Gabriel Orellana, saludos Dani, espero verte mañana. Coral también, acá. Rubén dice, yo vuelvo en 3 minutos. No vuelvas, Rubén, ya no vamos. Vi que sufrió un daño por una tormenta en una unión y creí que corría el riesgo la misión. Yo también, sinceramente, Pablo. Dice que hicieron un análisis de riesgo y esa parte que falló, en realidad, para ellos...
We could not complete your call. Please try again.
Y que para ellos, en realidad, eso no es un riesgo. Acá lo estamos viendo. Lo estoy colocando. ¿Ven? Bueno, esto que se ve acá debería ser igual. Parece un pegote, una masilla, un multicapa, le dicen ellos. ¿Ah? Como que está decapado eso. Y bueno, la pregunta es, en realidad, si esto el resto que quedó se despega durante el lanzamiento, si no puede causar daño en algo de lo que está abajo, más abajo en el cohete. Y ellos dicen que hicieron un análisis del riesgo que en realidad se da cuando el cohete llega a los Mach 2, o sea, 2 veces la velocidad del sonido, hasta Mach 3,5. Porque más arriba de eso, el cohete ya está muy alto en la atmósfera, la densidad es tan baja en la atmósfera que esa pieza no tendría resistencia aerodinámica, entonces no tendría energía suficiente para bajar y golpear alguna parte del cohete. Y luego dice que las partes del cohete donde podría llegar a golpear más críticas serían en la unión de etapas, pero que por la forma que tiene el cohete ahí sería también poco probable. Entonces, haciendo un análisis de riesgo, llegaron a la conclusión de que pueden correr ese pequeño riesgo que no va a incidir en el lanzamiento, en el total de los riesgos del lanzamiento, porque ojo, lo que hace el equipo de lanzamiento, todos los equipos, es manejar riesgos. El riesgo de la falla de un motor, el riesgo de la falla de un sistema eléctrico, el riesgo de la falla de un sistema hidráulico. Entonces, todo eso tiene sus riesgos, son todas partes mecánicas. Entonces, esto lo que agrega es un pequeño riesgo adicional. Dice que es tan bajo que no incide en el total, que de todas maneras dice lo vamos a monitorizar, obviamente. Y respecto al conector, ellos dicen que ese conector lo cambiaron, cambiaron parte del cable y que aparentemente estaría solucionado, solo que no se está comportando del todo bien. El término que él utilizó, dijo que se está comportando algo funny, algo divertido, no es divertido en realidad. No sé si tiene alguna otra traducción que se ajuste al español, pero en realidad es como que hay alguna falla cada tanto intermitente. Lo que dicen es que de todas maneras tienen redundancia en los datos, entonces tampoco es una cosa que les preocupe. No sé hasta dónde llega todo esto que no les preocupa. Pero bueno, eso es lo que están diciendo. Lo que sí dijeron es, el lanzamiento se mantiene en hora, va a salir tal cual como estaba previsto el 16 a las 06:04. 2 horas antes nosotros comenzamos el streaming. Vamos a tener otro streaming mañana antes, así que los espero a todos, nos vemos allí. Gracias a todos por haber participado de este streaming. Un abrazo enorme, me voy a cenar. Scotty, por favor, Scotty a la cocina.